guys, today, sorry, first of all, sorry that I'm absent again today, but I have a sick child, so I need to be there. But I came in tonight to teach it to you so you could understand what's going on. We're going to look at lesson 8.4, which is properties of rhombus, rectangles, and squares. Before I get into it, make sure you look at Google Classroom. You're not going to turn your homework in from last night until Thursday, so hold tight onto that. If you need to staple it and go ahead. But other than that, everything is listed on Google Classroom. Just make sure you look at that. I expect you to be just as respectful as you would be if I'm there, and I know you'll do that, but just a little reminder. All right, let's look at rhombi, rectangles, and squares. A rhombus is a parallelogram with 4 congruent sides. So if you look at the picture I have below of the rhombus, side AB is congruent to side BC, which is congruent to side CD, which is congruent to side DA. So you can see that all there. Because it's a parallelogram, we know already that opposite sides are parallel. And remember, how can we figure out opposite sides are parallel? By finding the slope. They have the same slope. Opposite sides are congruent. We'd use the distance formula for that. Opposite angles are congruent. Consecutive angles are supplementary, which means they add up to 180. And we know that diagonals bisect each other. And remember, diagonals bisect each other to form 2 congruent segments on each of those diagonals. Okay, because it's a special parallelogram, it has several additional properties. So the additional properties that it has is the diagonals are perpendicular. So if you look here, if I go ahead and draw my diagonals, what's going to occur there? Well, you know you're going to get some perpendicularness. We're going to get some 90-degree angles there. So we can say that AC is perpendicular to BD. It forms 4 right angles. And if we wanted to know if these two, if the diagonals were perpendicular, does anyone know how we can figure out if the diagonals are perpendicular? Remember, if that's the case, their slopes are opposite reciprocals. So remember, if one slope is 3, the opposite reciprocal would be negative 1/3. If one slope is negative 4/7, the opposite reciprocal would be 7/4. So you take the opposite sign of it and flip that fraction. The other thing that makes it a special parallelogram is it has the properties that diagonals bisect opposite angles. Okay? So where my diagonals are, they bisect opposite angles. So this angle is congruent to this angle is congruent to this angle, and these are congruent here. So that's another thing that makes a rhombus a special parallelogram. All right, let's go ahead and look at a practice problem for a rhombus. All right, so draw rhombus PQRS with diagonals intersecting at point 2. So PQRS, and the diagonals intersect at point T. So I'm going to go ahead and draw my diagonals here as best you can. Clearly mine is not very good. So point T is right there. So it told me that it is a rhombus, so I have to assume all properties of a rhombus. So ST is 13. Find SQ. Well, ST is part of the diagonal, and don't the diagonals bisect each other? So if this segment is 13, this segment is 13, SQ is the whole thing. 13 plus 13 equals 26. If the measure of angle PRS. So PRS is this one right here. If that's 17, what is the measure of angle QRS, which would be the whole entire thing right here? Well, if this one's 17, don't the diagonals bisect opposite angles? So wouldn't this one be 17? Then the whole thing would be 17 plus 17, which equals 34 degrees. All right, the measure of angle STR. So think about where STR is. That's this angle right here. Well, we know that diagonals are perpendicular, so if they're perpendicular, they make 4 90-degree angles, so that has to be a 90-degree angle. PT, where is PT? All right, how am I going to find PT? Well, I know if this angle is 17, this angle is 17, don't these two angles appear on 17? And isn't PT this part right here? Well, think about it. I got a little triangle right here. I don't know that side. I want to find that side out that I just drew. I know this side is 13, and I know this angle. So think about how you would find side PT. If I'm at this angle, I know the opposite side is 13, and I want to find the adjacent side. So what deals with opposite and adjacent? That would be the tangent of trig ratio. So the tangent of that angle, which is 17, equals the opposite over the adjacent. I don't know the adjacent. Get x out of the denominator. And then in order to solve for x, you need to divide by the tangent of 17. So you get x equals 13 divided by tan of 17. And if I go ahead and use my calculator, I need to make sure that I am in degree mode, and I actually am. So it is, make a fraction, alpha y equals, number 1, 13 divided by the tangent of 17, and that gives me, let's round to nearest tenths there, so 42.5 degrees. Oops. So side PT is, oh, I'm not talking about a degree here, I'm talking about side length. So side PT is 42.5. All right, let's see what I got now. So SP, this part right here is 4x minus 3. PQ, this part right here, is 18 plus x. How am I going to go ahead and find x? Well, what do you know about if it is a rhombus? And if it's a rhombus, my opposite sides are going to be congruent. So SP would have to be congruent to PQ. Therefore, 4x minus 3 is going to have to equal 18 plus x. So if I do my math here, I get 3x equals 21, so x has to equal 7. So in order for that to hold true, x would have to be 7. All right, let's go ahead. Let's go on to our rectangle. All right, a rectangle is a parallelogram with 4 right angles. Because it's a parallelogram, we know that opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, meaning they add up to 180 degrees, and the diagonals bisect each other. Because it's a special parallelogram, it also has another additional property. The diagonals are going to be congruent. So if I go ahead and draw my diagonals in here, let's go ahead and label this G, E, O, M, and they touch in here at T. I know that this is congruent to, all my diagonals are going to be congruent. Okay, so GO is congruent to EM, diagonals are congruent, but also each part, GT is congruent to ET, which is congruent to OT, which is congruent to MT. Okay, let's look at some practice problems with that. So draw rectangle EFGH. So here we go, EFGH. With the diagonals intersecting at point D. So if I go ahead and draw my diagonals here, they intersect at point D. If HFG is 48 degrees, this angle right here is 48 degrees, and EG, this whole entire thing is 18, what would that mean? If that whole thing is 18, aren't these parts congruent? So wouldn't this be 9 and this be 9? See if I can find the following. All right, if I want to go find EF. So think about it. EF is this part right here. Okay. So let's see where I can go. I know that it makes a 90-degree angle right here. So if this angle is 48, what does this little tiny one right here have to be? And that has to be 42. Well, don't I know that this is a 90-degree angle as well? Look at what I got going on here. Look at this triangle. I'm going to pull that triangle out. So 90 degrees, EFH. You know that this angle here is 42 degrees. What would this angle down here have to be? If this is 90 and this is 42, what does this one right here have to be to add up to 180? And it would have to be 48. Okay, now, somehow, and I also know, don't I know this whole diagonal here? Isn't this whole diagonal 18 if this other one is 18? So this whole thing right here is 18. I'm trying to find this side right here. What can I use? I got a right triangle. Does it matter? I can use a trig ratio. I know the hypotenuse, so wouldn't I have to use sine or cosine? And that really just depends on if you want to be at this angle or this angle. It doesn't matter which one you want to start at. I'm going to go to this one right here. If I'm at the 42, I want to find the adjacent, and I know the hypotenuse. So that would deal with cosine. So the cosine of 42 equals x over the hypotenuse. Solve for x by multiplying both sides by 18. If I go ahead and do that, 18 cosine of 42, make sure you're in degree mode. 18 cosine 42. And I get about, what, 13.4, let's say, around to the nearest tenth. So I get 13.4 for this. So I know that this side is 13.4. Well, then wouldn't this side HG right here have to be 13.4? All right, let's go ahead and see where we can go from here. Find a measure of angle FHG. FHG is this one right here. Well, again, I have a 90-degree angle. If I look at this triangle I have right here, I already knew this one was 48. I know this is 90. What does this one have to be to give me 180 degrees in this one block triangle? It has to be 42. So FHG is 42 degrees. DE is right here. We already figured that out. That's 9. I get a lot of colors here. Where's H? HDG. HDG. Isn't that this one right here? How am I going to find that out? So let's pull out that triangle. HDG. I want to know this one right here. Well, where am I going to go here? If I know that this is 42, okay, and I knew that this one right here is 90 degrees, but I only have part of it right here. Well, what does that one have to be? Wouldn't this be an isosceles triangle right here? Because if these diagonals are congruent, aren't those sides the same? So the base angles have to be congruent. So wouldn't this side have to be 42 degrees also? And then all the angles, because this and this are congruent, so it's isosceles, base angles are congruent. All the angles inside of the triangle add up to 180. So 42 and 42 is 84. 180 minus 84 gives me 96 degrees. Last part. How am I going to find EH? That's this side right here, which I have from this triangle over here. If I go back to that triangle over here, what can I do to find side EH? Again, does it matter if I'm at this side or this side? Or this angle or this angle? I know the hypotenuse, and I want to find one of the sides. Remember, you can either use sine or cosine if you know the hypotenuse. I'm going to go to this angle right here. Well, adjacent to it is the side I want to find. So adjacent and hypotenuse, well, that's cosine. So the cosine of 48 degrees equals x over 18. Multiply both sides by 18. 18 cosine of 48, what do I get? 18 cosine of 48. And I get about 12.0. That doesn't really round me anyway. It's a lot. It's a lot to do, but we also, we're using a lot of skills that we've already used in right triangles and incorporating them into what we now know. All right, moving right along to square. A square is a parallelogram with 4 congruent sides and 4 congruent angles. And think about those 4 congruent angles. They all have to be what? Right angles, so they're all 90 degrees. A quadrilateral is a square if it is both a rhombus and a rectangle. So keep that in mind. A lot to remember here. List all the properties of a square. So if it's a square, we know it's a parallelogram, so then it has to have all these different things. Opposite sides are parallel. Opposite sides are congruent. All 4 sides are congruent. Opposite angles are congruent. All 4 are congruent again. Consecutive angles are supplementary, which means they add up to 180. Diagonals bisect each other. Diagonals are perpendicular. Remember, if diagonals are perpendicular, the slopes of those lines will be opposite reciprocals. Diagonals bisect opposite angles. And diagonals are congruent. So let's go on and see how we can solve the next problem knowing all those properties of a square. So go ahead and draw your square, A, B, C, D. So A, B, C, D, and it says with diagonals intersecting at point E. So I'm going to go ahead and diagonal intersects at point E. Do not forget, you have 90-degree angles here. And think about that. If you have 90-degree angles there and diagonals bisect opposite angles, what do each one of these angles have to be? Well, yeah, if they're 90, cut them in half, 45 and 45, right? That's going to happen all over, right? So think about this. How many triangles do you see? I see, what I got, 1, 2, 3, 4 triangles there. And don't these make right angles? So if I have 4 triangles there, they're special right triangles, and aren't they 45, 45, 90 special right triangles? I might have to use this here, so let's recall the rule. So the rule is what? X, the legs are X, and across from the 90 degrees is X radical 2. So we might need to use that. We're using our prior knowledge here. All right, let's finish. AD, if AD is 6, find all of them. Where's AD? AD is right here. So if AD is 6, what do you know about all the other sides? All the sides are congruent. So this is 6, this is 6, this is 6. Does that help me anywhere else? Well, it helps me right here. Where else does it help me? Doesn't help me anywhere else there, right? All right, so we'll have to go ahead and find all the other ones. So let's start from the very beginning. Find the measure of EDA, angle EDA. Angle EDA is this little angle right here. And didn't we just talk about how that's 45 because if the diagonals bisect opposite angles and they're right angles and they bisect here, each is 45. So go ahead and add that in. AEB, where is that? AEB, this angle right here. Well, didn't we just talk about how that those diagonals are perpendicular? And perpendicular means they make a 90-degree angle, so I got a 90-degree angle right here. So I kind of answered some of my questions in knowing my rule there. AEC, well, where is AEC? Angle AEC. Well, think about that. That's this whole angle right here. A 90 plus a 90 gives me a, very good, 180 degrees. All right, ABC. Where's ABC? Well, we already said squares have 4 right angles. So that's got to be 90. All right, let's get down to our, we already answered DC, because we know that all sides are congruent on a square. AE. AE is this part right here, this part of the diagonal. I don't even know the diagonal, so let's think about, I'm going to pull out this 90-degree triangle right here. And if I do that, A, E, B. I know it's 90 degrees because diagonals are perpendicular. I want to find this side right here. Well, you told me this is 45 degrees, this is 45 degrees. I know this is 6. Isn't that the side across from my 90 degree? If that equals 6, what is the rule for 45, 45, 90? X, X, X radical 2. I know this one. This equals 6. How am I going to solve for X? Go ahead and divide by radical 2. So I get what? X equals 6 divided by radical 2. I can't have a radical in the denominator, so go ahead and rationalize. Multiply the top by radical 2 and the bottom by radical 2. So what does that leave me with? 6 radical 2 divided by radical 4, or 6 radical 2 divided by 2, which doesn't that equal 3 radical 2? So I know that AE, this part of the diagonal, is 3 radical 2. Well, let me ask you something. If this part of the diagonal is 3 radical 2, what's this part of the diagonal? They're both 3 radical 2 because the diagonals are congruent. Or diagonals bisect each other, which makes them congruent. So in order to find the whole entire diagonal, you take each segment 3 radical 2 plus 3 radical 2. When you're adding like radicals, keep the radical and add the coefficients ahead. So 3 plus 3 is 6. All right, let's go ahead and find BD, and then you can get started on your homework. Well, think about this. What's BD? Looks to me like BD is the other diagonal. Aren't diagonals congruent? If I already found one diagonal, which is AC, because I found each part and I put them together, do I even need to do any work for this one? No, it's just 6 radical 2. All right, go ahead and check what you have on Google Classroom. I know that was a lot, but if you need to rewatch it, go ahead and do that and get started on your homework.